Our business is Select Spectrum. It's a small group of folks. We specialize just in licensed spectrum. We do it, as I mentioned, for carriers and for wireless ISPs. We've done over 400 transactions. We're representing most of the band. I'm going to talk about 6 different bands today, but not all. So because now there is broadband spectrum, which is the wonderful thing for the utility industry, kind of bringing together the place I started in broadband and the place that this line of our business, utilities and critical infrastructure. And I'm excited to be here. I really am. Okay, so lots of use cases. You're going to see a bunch on the 2 different showroom floors. You're going to hear about lots of them. I guess the point I wanted to make on this is there's going to be a constant stream of new applications. That's great. Some of them are better done on narrowband. Some of them are even better done on non-3GPP applications, right? And that is very much an issue of each utility doing an evaluation. It's a great opportunity for the consultants, but also for the people inside the utility to really sort through what's the best application for each site. We offer a variety of these. There's a variety of licenses. If your application is not on this list, please come and see me. We'll post this, by the way, at the end. I imagine UBBA will as well, but it'll also be on our website. And my view is these applications are going to make your companies work better. They're going to make the consumers happy. Done right, they're going to save money. Done right, they're going to increase availability and reliability, and that's a very positive thing. And this is an industry that overall is exceptionally reliable, the utilities industry. But when it's not, the consequences, including loss of life, including business interruption, the cost of that is huge. And there's been a study. I think EPRI was involved in it. Altogether, billions of dollars of capital that should be spent every year if you were sort of doing the overall optimization that doesn't get spent. We're in a place to influence that, to accelerate that, and that will be good for your companies and for your customers. Let's see. I mentioned here, within the 3GPP space, it's worth mentioning, some of these are going to be served more cost effectively on NB or Cat-M1 or the successors that are NB-IoT, narrowband or Internet of Things oriented technologies. So, we have the name in this group. We're now a member of this group, but I really am encouraging the UBBA to look at what's the optimal technology for each. And it may be that, you put in a broadband network that serves everything. My guess is you'll be also looking at some of these flavors that are really intended for its IoT, and therefore the economics of those lower cost, longer range, whatever it is, may make a lot of sense. So I don't think I have to convince this group too much about the importance of 3GPP. So this is our standards organization. Obviously, it had a name before 3G came along. I've forgotten what that was. Maybe somebody here will recall that. They haven't bothered to change the name to 4GPP or 5GPP, but it's been an evolutionary experience. One of the bands I'll be talking about was previously really only an industrial radio band and has been recently approved by 3GPP, so now it fits into the 4G and 5G standards. Today, you're going to hear private LTE. That's the common denominator that you're going to hear from most of the presenters. It's the system that you'll see. That is the practical, real world available endpoints, increasing number of devices. All of that's very positive. From a spectrum perspective, I encourage you to think about 5G. So, number one reason is 4G's been around more than 10 years now. The carriers, if you look at your phone, in most places in urban environments, it'll say 5G on it, right? So that is where the development is going in the carrier world. It's not really yet where the development's going in your world. It doesn't mean you should wait, right? Most of these companies will have solutions. I, by all means, encourage folks to get out there, get involved, because there's always going to be this succession. But knowing that that's coming, I would encourage you to look for spectrum that has a path to get to 5G, and that's not all spectrum bands. And when you get to the corner office, they're probably going to ask, right? So to be ready for that question is my suggestion. All right, so these are the 6 different bands that I propose to talk to today. This is a US-centric approach. It's a utility-centric approach. There are lots more spectrum bands in the United States than these. These are the 6 that I think are worthwhile. For those who want to, we can bring up any other. If you think I'm missing one. 5 of these are broadband licenses. My definition is at least 3 megahertz carrier width and up. Some people say 1.4 carrier width. I guess 3GPP would say that. But for practical purposes in this group, that includes all of these except the 700 megahertz A block. So why is that relevant? Why bother to include it? Well, first of all, about a third of the country has critical infrastructure companies that have acquired this band. We've sold a good chunk of this band, so is a company called Access Spectrum. And I didn't come last year. This was the main thing we had. We could offer some CBRS pallets as well, but I didn't come last year because this band had not yet been approved for 3GPP. So now it has. It's a 4G, 5G band. It's the world's first 4G, 5G NB-IoT only band, right? So it's only 1 + 1 megahertz. It's not wide enough for broadband spectrum. It won't support all of those applications, but it will actually support the majority of them. So I'll talk a little bit more about that. And I guess as I go through these bands, 5 of them are, you get a license, it's yours to use, nobody else gets to use it, you can enforce the situation, there's no third-party database. CBRS is different, right? So I think probably everybody here knows about this broadband radio service. It's much higher frequency. There's a GAA, General Access, Authorized Access tier. Anybody can apply to use it if it's not full in that particular area. The SAS, the Spectrum Availability System, will tell you, yes, you can use it. You get a temporary right to use. So that's a different structure. There are also priority access licenses. I'll talk a little bit more about that. But just kind of think of that as it is a license, but it's different and has, I guess, less flexibility and some more requirements. All right, so let's go on here. So this is the first of the bands I'm going to be talking about. I'm going to go low to high in this approach. We are not currently representing any of the holders here. With all of these, I'm going to try to be fair and equal, but by all means, if you think I'm not covering things appropriately, let me know. So 600 megahertz is predominantly a T-Mobile band in the United States. Dish Network has also leased capacity to T-Mobile. Columbia Capital acquired the licenses that AT&T acquired in the auction and then resold them to T-Mobile. So it's kind of all flowing towards T-Mobile. There's some Comcast as well. Excellent propagation. Lots of devices. Obviously, T-Mobile is on the consumer side. There's plenty of devices. So that means chips and modules are out there and available in quantity. It benefits, as all of these bands do, from the kind of security standards that are available through 3GPP. The issue here, and we have had, it was widely publicized, NIPA did a test with this spectrum, and I see Nokia was involved, perhaps others. I think they were very satisfied with it. We haven't seen a follow-on announcement. So we know the owners of almost all of this spectrum. In the majority of the country, it's T-Mobile, Comcast, companies like that, Dish. Utilities are not very likely to wrest that away from those entities. They want to hold on to this. I used to work at Nextel and Sprint. The number of sales or effective leases to third parties is pretty low. It does happen. There's some stuff out in the oil fields, for example, where there's kind of no people. But in terms of major cities, you're going to have a hard time getting this. remainder of this is available in some parts of the country from investors. In general, I think that it's kind of surprised to me, there's more available in the eastern half than the western half that could be potentially available. They all stand to make a nice profit if they sell it to you, because the dynamics of this auction 10 years ago, something like that, were that AT&T dropped out early, Verizon didn't compete, so it was kind of Dish versus T-Mobile, and so it didn't have the same level of high bidding that occurred in a lot of places. So they didn't pay a lot for some of these licenses, and doesn't mean that they're going to sell it for a particularly reasonable price, but at least it creates more of a possibility. And I think that in your shoes, if I were looking at different frequencies, this is one I take seriously. I just figure out who has it in our area that's available through ULS. There's always a contact person. You talk to us too, we usually know the folks there. As I said, we're not representing anybody in this space. And have a look. I would also ask, and I don't really know the answer to this, go to the manufacturers and say, for the specialized devices that I want, are they available for $600? You want a mobile phone? Guaranteed. You can get an iPhone, whatever you want. You have to figure out all that SIM stuff that other experts can tell you about. But for the specialized devices that you need, not sure. Seems like it's a doable thing. But because it's only available in a minority of the country, there won't necessarily be demand from lots of utilities for those that could affect it. I think that covers 600. So some of you in this room have heard me talk about 700 megahertz A block a lot of times. But raise your hand if you've heard this before. Chris, Jim. Well, that's not too bad. Okay. Well, again, this is a broadband convention. I won't dwell too long on it. I'm completely conflicted here as that we're representing parties, but I'll try and give you a fair assessment. The reason the utilities like this, there's plenty of equipment available. When we started, there wasn't, and there's now a dozen different manufacturers making equipment for this spectrum. There's predominantly data solutions. There's also some voice. It's been, heretofore, it's been what I call industrial radios. Some people call them proprietary systems. They're designed to provide relatively low latency, relatively high bits per hertz, right? So there's not a lot of hertz here, totally 2 megahertz. Relatively high power, so you get long range. They're not super cheap, right? They're fair price, but you're getting good quality. So that's been the majority of the deployment. So that gives you an idea. They have equal protection from their neighbors. 30 watts uplink, right? Over 1,000 watts. You're never going to use all of that in the downlink. And like 600, excellent propagation. These are the industrial radio size. So the new news, and the reason I'm presenting this here, is NB-IoT. So Neurband IoT is a 4G and 5G standard. It is designed for very long range, low throughput. We're talking kilobits, right? Tens of kilobits type numbers, can be more if you bond them together. Low power consumption. That can be battery powered for years if you have an application where, let's say a gas meter, it wakes up and it transmits once a day, right? 10 years maybe, battery life. And because NB-IoT is designed for very long range, so I said this in the last conference, I said 25 miles non-line of sight. So, fixed location, you have the antennas. A guy came up to me afterwards and he said yes, is what he said. So I've done the research. I talked to, there's quotes here from Qualcomm and Ericsson that say this is 20 to 25 dB better than broadband link budgets. Not because it's 700 megahertz, because of the difference of NB-IoT. So what does that mean? I don't understand all the details, but they are expecting interference. They're expecting impediments to that. It's a fixed application, so they're not dealing with the mobility issues. And so I'll come back to this, but this is a standard for covering potentially lots of things, but not lots of very talkative things, right? And you know, that's the overall situation there. That covers that. Okay, I'm pretty sure everyone here has heard about the 900 megahertz broadband service. This is exciting, and I admire, and we are not representing Anterix, but we have a lot of respect for what they have done. You know, in many ways, they got this whole organization going. They've been through a difficult process at the FCC. They've got a favorable ruling, and they have 3 plus 3 megahertz of FDD spectrum. So this is the third group of frequency division duplex spectrum that I talked about: 600, 700, 900. Transmit and receiver separate. You know, that's an advantage. You have continuous capability in both ways. Your total throughput on any of those 3 FDD systems will be limited by, you know, what's your maximum, where do you have the maximum demand. So in most utility applications, there's various items in the field explaining, here's, you know, current status, change, information, and then you also have transmission in reverse, right, downlink, to say, execute this command. We've seen, my opinion, and I'd be very interested if somebody had a different perspective, that most utilities have more uplink than downlink. That seems some nodding head. So, and by the way, the uplink is usually, from a radio perspective, a more difficult path, right? So you'd be able, typically the modulation speeds in the uplink will be, or modulation complexity and bit rates in the uplink for a given path will be lower than in the downlink. So what this means is, you know, you engineer this to the uplink, and if in most cases, so something to keep in mind. This is a version of 3GPP band 8. It is a different duplex spacing. That's this, the active ecosystem seems to be taking care of that. There's quite a lot, and we're about to see, I'm excited to see all of the things that are happening out there. The way this happens, by the way, you know, this didn't suddenly appear, right? So smart folks went to the FCC, said, you know all those narrow slices? We, at that point, it was Pacific Data Vision, was the main advocate for this. We would like to turn them into a broadband system, and in order to do that, we're going to move the narrowband to one portion, the narrow slices. We're going to occupy the broadband, and we'll be able to use LTE type technologies for that. So that's the process that is underway. So they've started that spectrum clearing effort. They're also calling it band reconfiguration, I believe, and realignment reconfiguration, one of those. So this is a process. It's been done. Some version of this was done before in the 800 megahertz. That was called rebanding. So some of you may be familiar with that project as well. Let's see what else I can tell you. So, good uplink power, good downlink power, good propagation. Not quite as good as 600 and 700 does. And so compared to 700, it's got much more speed because it's broadband, and more limited range compared to the NB-IoT. So that's the trade-off. And in many cases, the broadband will really dominate. I don't know, we probably have somebody from Anterix here. Did I miss anything that should be said here? Because, or we may have some advocates. If I did, stop me later. That would be fine. Honestly, this is the main reason I'm here. This is what changed from last year to this year. In January, we announced that Select Spectrum is representing Legato Networks. Legato is offering the 1670 to 1675 megahertz band. This is a 5 megahertz, and it's the first time division duplex band. So that means that you have the flexibility, you know, it's a transmit and then receive in assigned amounts. You have to figure out what your ratio is. But if you have 80% or 85% of your traffic that is coming up, you assign 80 or 85% or more because of this difference in the relative efficiency of the uplink versus the downlink to the uplink band. So our version is that effectively for most utility applications, you're getting more efficiency. You're using both the uplink and the downlink more efficiently. By the way, that there is some very small amount of time lost in between, right? So that's a minor factor. But overall, if you have any significant asymmetry, particularly asymmetry in the uplink direction, where you're doing more uplink and downlink, this should be more efficient. Significantly, this is available nationwide today, right? So I haven't been able to say that with any of these other bands. If you want to do something, if you want to, lock down your spectrum, this is a place where you can do it. The ecosystem on this is getting going, right? It's not anywhere near as far along as any of the other bands that I've spoken about so far. But we're seeing a lot of excitement, both among prospective users and among the equipment companies. But clearly, this is the area that we need to develop. Also worth mentioning, so the mobile station here is set at 4 watts. That's good. But the fixed station can be up to 2,000 watts. Now you're not going to, so if you have a fixed device, the spec says it's not just the base station, but the remote could be transmitting at very high power. So propagation at 1600, this low mid-band, still very good. Not quite as good as the true low band spectrum, but there's some option here to overcome any distance limitations with power. The engineers will tell you got to balance that, and there's questions of are you going to create self-interference and things like that, but you do have significant power here. So this is a full 5 megahertz channel. So that is, and this is submitted for 3GPP approval as a 4G band. By the way, Legato also announced when they first went through this that they had band 24, 30 megahertz, but very low power. And what we found is this industry isn't interested in 200 milliwatts uplink, and they have other options for what they're going to do. But they went through the whole approval process at 3GPP. They got 4G approval, they got 5G approval, they got carrier aggregation, supplemental uplink. I'm probably missing something, Mike, but they did a lot. And NB-IoT and CAT-M1. So they've been through that process. They know how to go through this process. We expect to have the 4G band identified by December of this year, 2022, 2 months away. And then to go through the process as well with 5G and the CAT-M1 and NB-IoT. It's great spectrum, almost 200 megahertz. Not the best propagation. It's also TDD, by the way, so you get that. The problem with this is it's kind of all tied up. There is a person at Select Spectrum who works on this all the time. As I said, I've kind of moved over to this aspect of the business. I'd be glad to introduce him. Andreas Bitzarakis is his name. Very capable, very creative guy. Many of you probably have met him. He also works, by the way, on the CBRS band. So, again, most of you probably know about CBRS. It is widely available. So GAA is available everywhere, except if there are 8 other parties that are using it in the particular, or 7 other parties, 8 other parties that are using it where you want to. There's also 7 priority access licenses per county. These were licensed on a county basis. So county actually fits what utilities want to do a whole lot better than the usual licensing territories, which are larger. Should mention partitioning is always possible. So our owners typically will divide PAL, priority access license, into less than a county. We'll divide a major economic area in the 700 into a county. Usually there's a way to match pretty closely to what utility territories are, and the FCC allows all of that. So what's different here is for both the GAA and the priority access tier, there's a spectrum access system. Google runs one. Federated Wireless is a bunch of ex-Nextel people at the top of that as well are running a SAS. I'm not a complete expert on this, but in general, we see this as a relatively low power service, right? It's intended to not be super high power because different parties are sharing it, and the SAS is keeping track of that. And there might be more than one trying to use the same license in the same county. So some power limits there. There's a government tier. So if the Navy comes streaming in here with their radars on, you may have to shut down your transmission. In general, I view this as a relatively small area, dynamic area. Cover the port, sure. Cover the city of Los Angeles. I don't think so. I mean, it takes a lot of towers in that sense to do it. With these power levels and propagation, as I think everybody knows, the lower the frequency, the better, the longer the range of propagation. We're all the way from 600 megahertz to 3,500 megahertz. The propagation is not the same. This may be the most, if you have that small area requirement, this may well be the most economical. We'd love you to come and check with us. With PALs in about 400 PALs in something over 200 counties, but there's 3,000 counties in the U.S. They tend to be, what's available so far is more rural as opposed to urban. We hope this is going to be, the closest thing to a market where, licenses change hands, they get subdivided, they're used for a period of time. This is, part of what the FCC is trying to do. The concept is making full use of this valuable asset. The FCC is looking at this in concept in other bands as well. As a utility, you may have different criteria. I think of utilities as being long-term, security, reliability, but we would love to work. And there were several utilities, including Southern California Edison, including San Diego Gas and Electric, that acquired PALs in the last auction and invested many millions of dollars to do so. There are higher power limits, depending on which CBSD is effectively a base station type device, so different power limits depending on where it is and how it's installed. What else do I have to say about CBSD? CBRS, I think that's it. So maybe I should ask, is it, because I'm about to go to a comparison slide, which is sort of my view of the pluses and minuses of the different bands. So on this slide, it doesn't show particularly well in this. So dark green is supposed to be really good, excellent. Green is good. This is supposed to be yellow, kind of fair. And again, all of these, we intend to make these available. This is subjective, so please, feel free to dispute any of these squares. So first of all, I'll go through them one by one, and stand up. I got told yes after my last presentation, and it wouldn't be the first time. I think it's important to be 3GPP standardized. I think the gold standard is to have 4G and 5G approval. We don't have that in 1600, 1670, 1675. We don't have either. We think we're going to have 4G very soon. You should check with Anterix on this. My understanding is 4G approved. They have an initiative to get 5G approval, even though today the standard says minimum for 5G is 5 megahertz. So get their perspective on that. But hopefully, both of these turn to green, right? And in which case, this row would be all solid dark green. Propagation gets better gets worse as you go up. It's best at the low end of the band. Where you draw that line is an interesting question. Here I'm giving them credit for the fact that they can go to higher power if they need to on fixed locations. But certainly all of this, the below 1 gigahertz could be considered excellent propagation. 600 has pretty limited power. I think it's 3 watts. So that's good, but might not be great in some of your remote locations. This is kind of a restatement of the contiguous channel bandwidth. So So obviously 1 plus 1 is not very good. I'm saying 3 plus 3 is also good, but could be better. You know, the rest of them are 5 megahertz or better. I'm curious, and part of what I hope to find out as we go through this, and UTC is actually doing some work on this as well, is what's the total demand for a typical utility? You know, how much is needed? Every commercial, every communications business I've been in, you give them, you know, the equivalent of a megabit, and they want a gigabit, right? And so if you go through the same, you know, maybe there's more. And I'll kind of come back to that. Throughput, you know, not so good with 700. Good on the rest. To get up into the higher frequencies, tend to have wider bandwidths, and you know, part of the advantage there too, advantage, disadvantage. If your propagation goes farther, then you're trying to serve a wider area. You shrink it down. This is why they split cells in the cellular business, right? Put all that capacity in place. Very good penetration, building penetration at these lower frequencies, less so at the high frequencies. So availability, we think this is important. Come and see us, you could be the first one to lease in 16 seconds. Ask Anterix, I mean, they're marketing it widely. They have clearings too, but you know, I think widely available. We still have it we're about 2/3 of the country. And then, yeah, some of the, you know, you're not gonna find them at 600 megahertz. CBRS, PALs, you know, so far it's a minority of the area. Yes, sir?
Is there a reason to not include AWS and PCS spectrum here?
AWS?
And PCS.
And PCS. Yeah, because I don't think you're going to get it out of the hands of the carriers in most cases. That's the view. So prior to this, for those who attended, there was a section on how else, other than fully private networks, could you have a semi-private network? And you know, there are options that you could go with the carriers that will give you grades of service, or maybe operating off your core and their network, is what I heard explained. Yeah, these I think are the most viable bands if you want a truly private network. I'm going to skip this one. We can take you through this if you want to buy spectrum, but the bottom line, I think the worthwhile say here, figure out what you want to do. Do a deployment analysis, identify the spectrum. That all kind of comes together. I wouldn't buy the spectrum until I had some idea of what my applications were. I want to check the available equipment as well. Sometimes, in the past, I've seen utilities kind of get locked into a vendor, say, okay, we're going down this path, and they come to us and say, well, you know, where's the spectrum? It's too late, in my view. They should be evaluating what are they trying to do, but especially in the field area network, kind of, you know, trying to build a single network approach. All right, so I mentioned the prior discussion was about using carrier networks or partnering with carriers to do part of your services. Now I want to talk about what we did when I was at the carriers, and by the way, before even I was at the carriers. So the first step was build a low band network, get the widest coverage, not necessarily adequate capacity. So this was 800 megahertz cellular, then Nextel, also 800 megahertz. Then later on, Sprint and others came along and T-Mobile and said, okay, that's good, we need more capacity. We're gonna layer on mid-band spectrum. So that's and then T-Mobile, I stole their slide. They also have the millimeter wave stuff, which is, I think, pretty useless for utilities, right? Unless you have a very, very small area. So look at the bottom 2/3 of that slide. They call it layer cake. They have a bigger marketing budget than I do. I like duet. Some people call it heterogeneous networks. That's a little bit to pronounce, and I think that, to me, that deals more with if you were using industrial radio for some frequencies, and then 4G for your data. My view is this could be integrated, right? This could be, for example, 700 megahertz NB-IoT, very wide coverage. Won't serve all your needs, but will provide broad coverage. And then mid-band where you need it. So so I'm gonna actually skip forward first and then back. So this is an example. This is based on 9 miles at mid-band. We think that's a reasonable non-line of sight coverage area at 1620. It'd be bigger or smaller, 1670, I'm sorry, 1675. Be bigger or smaller depending on the terrain, depending on the power, depending on you know, what frequency you chose, but that's in the range of reasonable. And I still maintain 25-mile radius non-line of sight for fixed applications with NB-IoT in reasonable terrain. It might be hard around Pittsburgh. These were, you know, examples, and easier as you go east and Pennsylvania is flat. So if you think about it, you could build, if your urgency is, I need broadband in a dozen places, you could go build broadband in a dozen places, get the spectrum to do it, and you know that would be your starting point. The other approach would be get a lower frequency and provide coverage first, and then come back. So in these last 2 sessions, and first you've heard some consultants basically say you could share with the carrier and evolve into private. I'm saying you could go ahead and build the private and then evolve it with time. But if you're in the 4G, 5G standards bodies, you can, you know, those are a couple different options. So, duet, long range, if you use 700. Yeah, by the way, you get pretty good coverage also at 900, so that's an option for coverage. Where you need extra capacity, you could get it CBRS. In fact, I think Anterix has talked about this kind of an approach, is 900 plus some CBRS kind of integrated. And either way, you're benefiting from a huge global ecosystem. All right, we're getting close to the end. So I'll cover this briefly. The government is giving away our money to deserving entities. And if you take just these 2 programs, grid flexibility and reliability and resilience, those 2 together have $8 billion in them. You just divide by the population of the country and you assume that that all is going to go to utilities. That should be the equivalent of $24 per pop. So I think in terms of megahertz pops. If it was 700, where we have, let's see here, yeah, if it was 700, we're charging a little less than $1 per megahertz pop. You'd only spend 8% of that funding, and you'd have over 90% left for the project. And by the way, not everybody's going to win. So maybe you don't get $24 a pop, maybe you get $30 or $40 a pop. There's more spectrum at 1670, 1675, or other bands. The pricing will vary, right? This is kind of in the range of what it might be at 1670, and it's, you know, people have seen some public pricing from some of the other deals that have been done. So you'd spend a third and you'd have 2/3 left. So if the government's giving away our money, it should be, you know, some of it should go to their companies, and we encourage you to pursue that. All right, I told you I was getting close to the end.